Hi everyone. So we're picking up in the third video in the series, part two of our player script we were working on. So we're going to finish up this part two of the player script, and in the next tutorial we can move on to shooting for the player to be able to shoot lasers or missiles or projectiles. So we're just going to jump right back into what we have so far. So the last thing we've added into this script was the on engine power change, and basically it was simply updating this GUI text here with a readout for us, and it was also calculating our true engine power value. So we're going to go in and add some more functionality, and the next one we want to do is going to be a function that controls the fire coming out of the engines, basically that engine effects. So we're going to go void adjust engine effects. I always like to name things very straightforward and common sense so that we know exactly what they're going to do later. So in this function we just want to ask a quick question, and we just want to say left exhaust effects is not equal to null, and right exhaust effects is not equal to null. And then we're going to do some things in between these brackets. So all we're asking in this adjust engine effects function here is if the left exhaust effects, which is these particle effects here, if they're not null, not equal to null, which means they're not empty, something's plugged in, both of them, then do this. And this is another one of those sanity checks to make sure it's plugged in, and we're not going to be accessing something that's not actually applied into the script. So let's go left exhaust effects start size equals 1 plus engine power value times 2. We're going to take this line, copy it, and we're just going to replace right for left. Okay, and we're good on that. Now we're just going to copy and paste both of these. And I'm going to kind of delete these gaps. And instead of start size, we're going to go start speed. I'm going to copy it and just paste it in for both. And this one, I discovered a value of 3 is a little more visible. Okay, so that's it for this function. That right there is going to completely control the scaling and the size and the speed of these. I'll wait for it to compile here. These two effects. Okay, because on that particle effect that we drug in here, there's attributes start size and start speed. And if you notice in here, we are adjusting the start size and the start speed. We're also adding on the engine power value. So depending on the intensity of how powerful the engine is right now, that is going to change the start size, i.e. like that, and the start speed. So what you're going to get is like a bigger blast, like that. Engines are full speed. And it's really going to be based on this engine power value, and then I multiplied it a little to kind of enhance the effect. These are just numbers I found. I'm actually going to add the little floats so it knows it's a type of float. I found 2 and 3 worked good for me, and you'll see that here when this tutorial is done, the effect. You may want to bump these up if you want the effect to be more intense. You may want to drop them down if you don't want it to be so intense. So just like our adjustment for on engine power change, we need to call this function, otherwise it will do nothing. And we're going to do that down an update by simply calling the function right there every frame. We're going to want those particle effects to be adjusted every single frame of our game. This should actually be, this function is called every single frame of our game. Okay. So we're going to adjust the engine effects. Okay, easy enough. So now the next bit of stuff that we want to do is actually going to take place. It's going to be some calculations for rotation and impulse, and they're actually going to take place inside of the update function. So we'll just go down here, and we're going to say this transform.rotate, which is just rotating this transform of this player. We're going to say the turn rate times multiplied by time.delta-time and space dot self. Alright, space.self is a rotation around the object itself, not in the world. It's not in world space, it's in local space to just the player itself. Sometimes you get weird rotations if the rotation is based on the center of the world rather than the object itself. So this is just saying we're going to rotate this transform, this player here, locally to itself, not based on the world. So if it's over here, it would actually rotate like this, offset around the world, around the world center. Okay, and it's going to rotate by the turn rate. So that's a variable up here. Max turn rate. Okay, turn rate is actually just calculated based on what we allow for max turn rate, so we don't see that in the inspector. But by the turn rate, by the time that's progressed every frame, and around itself. Pretty simple, right? We're going to ask a question under that for something, and we're going to say, well, if the vector3 dot distance impulse, we'll explain this in a moment, impulse actual is less than maximum impulse change, and then times frame time that's passed each frame. Then we want to do something, so let's give it some brackets, and we want to say impulse, actual equals impulse. So what we're saying here is if the distance between these two vector 3's, so it's just like a distance between the two vector angles of impulse and impulse actual, is less than the maximum impulse change times basically the time during each frame, then impulse actual is going to equal impulse. In basic terms, really, this just says if the two vectors line up, then our actual impulse has reached impulse. They match now. We've actually reached the speed we were desiring to be at. So then we're going to say, okay, well, if that's not true, then else, in some brackets, because we want to do what the case is if that distance is not less than the maximum. We'll say impulse actual plus or equal to impulse minus impulse actual dot normalize times max. I lost my autocomplete. Max impulse. I don't know if that's max or maximum. We'll go with maximum impulse change times time dot delta time. And then we make sure the gap's closed. So we were asking this up here, and then we're saying else if this is not true, it's not less than it, which means it's still greater than it. Then the actual impulse is going to be, we're going to keep adding to it by taking the impulse minus the actual impulse, and they normalize it from 0 to 1. Okay, it's similar to clamping. Times the maximum impulse change times frame time, so delta time. Pretty easy. That just means our impulse is still trying to actually reach, or the actual impulse is still trying to reach that impulse, or trying to align. Under it, we're just going to say velocity equals this transform dot rotation times impulse actual divided by 10, and it's a float. Then we say this transform dot translate. Nope, that's a caps. That's not how to spell velocity, right? Time dot delta time, and this time we say space dot world. Okay, let's indent that a little. So basically, this is just a calculation for the velocity, and then translating this transform, which is really moving it by that velocity over frame time and in world space, so through the world. We're not actually trying to translate it around itself or through itself. I don't know how that would even work, translation locally, but this is world translation. So basically, that's going to be about everything we're going to add into update, except we're going to need to call another function. And lastly, this is going to be one of the functions where we want to check input. So we need input from the keyboard, right? We need to player control. Sometimes it guesses some weird stuff. So on check input, we need to call that every frame because input could change every single frame. So we're going to put that in update. We're going to call it right there. Okay, so we're calling it just like we're calling the engine particle effects, the engine power, and now we're going to check the input. So we want to do another sanity check in here. This equals no, then return. And we remember that the return is just like go back up to the top of the function and don't go any further in processing anything in this function. Just go back and start over again. So it kind of puts it into a loop until conditions are met. So what we're saying is if this is null, and by this it means this script. This is a script not actually here. But the irony of it is it wouldn't actually be able to even check for it if the script wasn't applied. But we're asking just to make sure it's not null. Okay. So the rest of everything that's going to happen in the check input function says, well, this is the case if it's not null, which means it is applied and it is here and it exists. So we're going to set some things here. Desired impulse input equals 0f. Desired x input equals 0f. We want to make sure the desired y input equals 0, float value of 0. We want to make sure the desired turn x equals 0, and desired turn, wow, it auto-completed that with an input. It just says x. Desired turn y equals 0. Okay. And then, so now we're going to do some calculations for these values based on the keyboard input. What these are doing is constantly, since this is being called from update, these values are being set every single frame. It's saying, hey, your desired input for the x, for the y, and for the impulse, and for your turn, your desired turn value too, are all going to be defaulting back to 0. And we're going to have to do something underneath here to force it to take a new value, and then when we're not forcing it, return back to these 0 values. And what you're going to see that as is, if we're not parsing it, what do we got here? pretty certain. Why are we opening another mono development? That's so funny. I think it was just a bracket I was missing because I leave so much gap and space. I guess not. Maybe we got too many brackets. Let's see what we got up here. Oh, it's max impulse change, not maximum. Maximus. Save that. Desired turn X does not exist. Okay, I must have typed something. Desired turn. Desired input Y. Wow, I'm actually missing a couple. So private float desired turn X. I'm just going to say it equals 0. Wow, I missed those completely. For a desired turn. Okay, can't believe that. Well, it happens. So we set those values to be defaulted to 0, and we're going to have to try to do some things to kind of force them to change. So this is going to be the heaviest part of our script, and it's honestly only about 12 lines long. So let's start out by doing desired impulse input plus or equal to input dot get axis thrust times the impulse sensitivity times time dot delta erg. Okay, so what this is doing is saying, hey, the impulse input, which is basically our engine power, is going to be, we're going to add to it. It starts out as 0 constantly, but we're going to add on top of that 0, plus the input get axis thrust, and then we're going to multiply that value times the impulse sensitivity, which is just the sensitivity factor for how rapidly it'll work, and then times, time every frame. Okay, so we're getting an axis called thrust, and then the desired impulse is going to equal math f dot clamp desired impulse input get impulse 2 comma times get max impulse 2 close it, and then the 2 closing brackets, and then we're going to apply it. We're going to say desired impulse plus or equal to desired impulse input. Okay, so basically we're saying this is our desired impulse input. Then after we get all that going, the desired impulse is going to be a value that's clamped, and I think we talked about that earlier, where it's going to say, alright, the desired impulse input can only have this far of a negative value and this far of a positive value. So it's taking this value and saying it can only be at the lowest this and at the most this. And these are going to be functions that we're going to get a value, send a value to, and return a value from down at the bottom later. We don't have them in yet. But this is like a secondary impulse value and a secondary max impulse value that we're going to compare against and all that. And then on this line here, we just simply apply everything and say, hey, the desired impulse we've calculated here is going to add on to our desired impulse input. It's basically going to allow our engine to ramp up based on using our thrust key. Now, an important thing, I'm going to Control S and save. We're going to see some errors because it's going to tell us that these values don't exist right now, and they don't. because we haven't created the functions for those values. But we have a custom input we created called thrust. There is no axis by default called thrust. We got to create that, and we go into Unity's input manager to do that. We'll go into project settings, input, and I created one. But I tell you what, is there, okay, we can delete that, delete that. Basically, you want to go through here and find one that isn't used, and you want to name it what you want your axis name. Ours is thrust. It's going to ask you for a negative button and a positive button. Alright, the negative button is going to make our engine rate go down into the negative. So we're going to just say the 1 key on the keyboard. Positive button is going to make our engine go up, engine thrust. So we'll do that. So that's all it takes right there. We have an axis called thrust. We have 2 keys mapped to it. We're set on that. Okay, so what we're going to do here is some copying, because now we have to check for the desired turn input. The desired, I believe it was X input, and we want that to just be, this is a built-in axis that you don't have to go custom set in the inspector. Vertical, it is the WS keys and up and down arrows. So, and that's going to be times not the impulse sensitivity, but the turn sensitivity. So this is our X input. We're getting the positive value of the vertical input. Okay. What next? Desired. Okay. And then we got to set the value for desired turn X, and we want to clamp that by desired turn X input. Get max turn rate, and get max turn rate. But for this clamp, we're actually clamping between the negative of the max turn rate and the positive of the max turn rate. So it can go no lower than this, no higher than this, and that's for our desired turn X. Okay, and then here we're just going to apply the value. Desired turn X is going to be plus or equal to the desired turn X input. That's it. We've applied our turning on the vertical. So that turning is going to be like this. If you want to think about the vertical turning, it's going to be around X. So it's like when the ship does this. Okay, the horizontal axis is going to be turning around Y-axis like this. So this is kind of like pitch. You could think of it in an aircraft as the pitch. That's what this section right here is doing, based on vertical keyboard input. This one is going to be, because I know, based off of horizontal input, and it's going to be the desired Y. And basically, all these X's are just going to become Y's, because this is all about the Y input rotation. Turn sensitivity, okay. Math clamp, desired turn Y input. And they're going to use the max turn rate. It's the same for the Y as it is for rotating around the vertical or X. That negative value of the max turn rate and that positive value of the max turn rate. And then we just say desired turn Y is equal to desired turn Y input. Okay. And then the last 2 things we need to apply is just finally, can't type right, finally send some of these values down to other functions below to do a little bit of calculating down there for turning and impulse. It's basically what they're both doing. Desired turn X. Let's send down the desired turn Y. And then in the Z, we're not doing anything because this is the turn rate, and we don't want the Z to be affected in the turn rate. So this is the Z. So the desired impulse, that's the engine. That's going forward like this. All these other things down here are turn rate. This is the desired turn for X, desired turn for Y, and nothing in the Z because that's the impulse. And so basically, we can hit Control S on that. And there's a lot of errors and things not existing because we haven't typed them in below. So we're going to go in and we're going to fill in some of this missing information. So the next thing we need to do is set up another function, void set impulse to float z. We're going to pass in a value to that from above. Impulse equals new vector 3 and then z. Okay, so what we're saying here is the overall impulse, the global impulse, is going to be a new set of vectors in x, y, and z. And for the impulse, we're going to pass in a value from elsewhere in the script down here in the z-axis. So it's for impulse in the z-axis, which is forward. Okay, simple enough. Like float, get impulse to, and then we're going to just grab a value for that impulse. We're going to read it. We're setting it here. We're forcing it to be set, and then this one we're going to just try to read a specific axis of the impulse, and that's in plus. I've typed impulse too much today. It's the z. We're going to return that value in the get impulse to function there. Well, float there. So the next one we need to do is another float. Get max impulse to. I'm not going to pass anything into these. They're just returning values for us. They get called elsewhere in our script up above. Return max impulse, and also in the z-axis. We need to know because it's impulse related, so it's z. So what else? Okay, turn rate. So those are we've dealt with the all the impulse stuff. This right here, and we're accessing this from elsewhere in the script. So just make it public to be safe. So publicly accessible. Let's finish up by setting the turn rate. No, not t, y. And float z. And we want to say turn rate dot x equals, here's that math f clamping again, because we need to just make sure these values stay within sane limits. And this is going to be a global limiter for all of this turn rate jazz. And we're going to copy this line, Control V, and basically it's a vector 3, so it has 3 axes. We just want to go in and make sure we're testing the turn rate on all of them. So it's just going to clamp the turn rate in these very specific axes, the x, y, and z. It's breaking down the vector 3 into each individual axis, and we're clamping it for each axis, the value of the float that we pass in here, by its lowest possible amount, -1, -30, whatever the max turn rate is, to its greatest positive amount, +30, +20, whatever we set. Okay, so hit Control S and save that, and then public void set turn rate vector 3 v. We're going to make a temporary variable in here, and set. I'll explain that in a sec. v.x, v.y. Oh, I forgot my comma. And v.z. I might have one too many brackets in there now. Okay, and so that's going to set in a custom new variable there for a vector, and we're going to set that turn rate, and it's going to apply these values. We read up top higher for these temporary set variable b here, and we set some turn rate calculations based on that. So, complicated, fun math stuff. So public vector3 get turn rate, and this is just going to return a value here, and return turn rate. This will give us a final value for that. And then the last little public float down here is going to be get max turn rate, not passing anything into it. And we're going to return another value, which is simply the max turn rate. We need that information. We did all the clamping and everything up here for that. And down here we can just say, let's return it and get that value. Okay, desired turn, either I misspelled something wrong, and I did. Ugh. Where was my spelling issue? I'm sure there could be other. Okay. I'm going to look over a few things here. So we've got the float version of our turn rate. We've got the vector3 axis of our turn rate. Okay, so I'm going to go back. We've set up, I'm going to go double check, project settings input. We've set up thrust, so it's named properly. Thrust. That's going to be our engine, and we set that to 1 and 2 keys on the keyboard. So I'm going to, okay, I'm turning to the left and right. And I'm rotating up and down. Whoa! That was awesome. Okay, so obviously our camera, wow, I haven't went back to the camera in a while. I believe earlier in the tutorial we created this empty game object and put it in here as a child, and we called it cam target, and we're just going to drag that in instead of using the player. So, alright. So, wow, cool. Okay, so we have 0% engines, and our particle effects don't look that big. We might want to tweak that. So when I hit the T key, 2 key, wow, particle effects are a bit much, right? And the camera needs a little tweaking. So let's give this a higher value. Let's experiment with a much higher value on that. Okay, 2 key. We get acceleration. And man, we can just really fly around this place. Okay, so I want to look. I'm going to bring the engines down by holding the 1 key. Maybe this bad boy will come to a stop. Yep. Okay, cool. And I'm going to take a look at these, and I'm going to see what we're setting these to. Okay, I think where we were making their size big, maybe 1.2. 1.2 is just a smaller value. And then the speed, I think, speed we could actually go up. Okay, so start size is starting at 0.5. I noticed that error I made. So we're starting at the wrong value. Okay. They should look better now. Let's hit play. Looks like the player hit the F key. And let's get a look at their size. Okay. So let's set their start size even smaller. Just say 2, because the particle effects are really starting to look it's too big. Okay. They're like blowing out the back of the motor or something. Okay. Not too shabby. They might start out a little too small, I must say. Alright. Well, one thing I think we could do is look at how our camera's following and say, where's our camera target? Let's bring it up a little, like 0.25. And let's bring it forward 0.5. So it's kind of sitting in the cockpit. Let's see what happens. Okay, so it's close when the engines are a little low. Okay, I like that. Oh, we are totally flying through space. I'm going to decrease the engines. We can kind of mess with these values. They're not going to persist, these values, but we can tweak them and then remember what we tweaked. So I like 4, and let's say 0.75. I'm going to save and save the scene. So basically, for all intents and purposes, the yeah, I'm annoyed now by these. So we're going to go 0.5. I like that for a default value. And I don't want them to grow so large. It looked ridiculous. It was blowing out the back of the ship. So let's multiply them times a smaller value. Oh, and update the fact that 4.5. Okay. Did that compile and grab that info? Okay. And then hit play. And give it some engines. Yeah, I could live with that much better. Okay. So when I press up, I go down. You know, I don't like the inverted flight controls. So I'm actually going to go and look where we're setting these inputs for the turn rate. So what we want is, we want the vertical turn here. So let's make this minus instead of plus. And so it should invert the axis on the keyboard for the vertical axis. Yeah, it does. Sweet. I just like that. It feels more intuitive to me that if I press up, my aircraft goes up. Now you hold down that 2 key, and its engine's full percent. What I like about this system, this is why we were calculating all this impulse 2 and impulse 1, was so that we could hold an engine value and we would continue to accelerate through space with that engine value. Okay? It's not like a temporary thrust that goes away. If anything, I think I would maybe make the camera follow a little bit, not as close, you know, like a default value of the camera maybe with the ship. Whoa. Okay, so we got some things we could set here, right? So you'll notice when I press the 2 key, it pretty rapidly, the engine accelerates really rapidly. And that's where oh, impulse sensitivity. That's where this variable comes into play. So we have it at 500. If I set it to, like, say 90 and we apply it, you'll see what I'm talking about. So hold down that 2 key and look. how much longer it takes to get up to 100%. So maybe if you have like a ship that has a much larger mass, the engines, you could simulate that the engines take a little bit longer to get up to speed. Whereas if this is like a very tiny, agile fighter aircraft with super high torque engines, look, I mean, boom, we're at 100% engine like immediately, which is kind of cool. Okay, so, and of course there are other values here, like we can increase that, and we'd want to increase the turn sensitivity. And now we can really start to jet around space. Okay, so the skybox is infinitely in the distance. We're never going to get any closer to it, so we're lacking a real sense of speed. We are, I'm just going to back out here and give you an idea how fast we're hauling butt through. We're moving through space, but in the game window, it doesn't look like we're really going anywhere, but let me try to bring us back into view. We're hauling butt in the game world. In fact, you can look at our velocity and stuff like that here. If you want to be able to go even faster and farther, you can go in here and change this max impulse to something in Z, something even higher. So this should be pretty impressive. So I get our engines going. We'll reach that max impulse. And by the time we get up to it, we should be really traveling. And we are. We're really hauling butt now. Okay. So I'll go back down to that. Felt like... No, that's good to go for now. So really what we need, because we're not getting a sense of speed, is I think we need a star field, or like stars flying past the player to let us know we're flying through space. Things need to be flying by. And we're going to use our camera and a particle effect to do that in the next tutorial. So I'm going to bundle it. No, in the next tutorial, in video 3, all we're going to focus on in that one is we're going to actually get this within a 20-minute limit. We're just going to do the particle effects for a star field around it. It's really simple to control that, and it has a lot of really cool values in the inspector you can change on the star field. So let's just save this, and in the next project we will set up some stars that will look like they fill the entire world, but in reality they're just going to be in a little sphere around the player. But when you're in the game, you'll never know. You'll think there's an infinite amount of stars in the universe around you. So we'll set that up in the next tutorial, video 3. So thanks for watching.